we're going to work on solving systems using elimination. We've done graphing and substitution. So first let's practice finding x and y intercepts. We know when we see something in standard form like this, ax, by, and c, it's often good to find x and y intercepts. Now this isn't a system, but we saw systems with word problems before where we had to graph. And usually when you're going to go graph with the word problems, we noticed that it was great to find our intercepts. So let's quickly review that. So to find an x-intercept, we're going to plug 0 in for y. So we'd have 3x minus 5, insert 0 for y, equals negative 10. I like to cross and divide by the coefficient of x. So I have x equals negative 10 thirds. So that would be the x-intercept. A y-intercept would be 3 times 0, y-intercept, 0 for x, minus 5y equals negative 10. So cross, divide by negative 5, and so your y-intercept would be 2. Now let's go back to some systems. Let's look at this one, solving a system using elimination. So you first have to make sure that your x's, your y's, and your constants are all lined up in columns. If you have anything that will disappear, then do it by adding or subtracting. Right off the bat, I see that my y's would cancel. So I asked myself, am I going to add or am I going to subtract to make them cancel? So if the top coefficient's 5, bottom's 5, am I going to add or am I going to subtract? Well, 5 plus 5 is 10, so we don't want to add. We want it to eliminate, become 0. 5 minus 5 is 0. Okay, check. We want to subtract all of the columns. So this is one option. So then in the bottom row, let's write the top row. 2x plus we'll go like this. Okay, so 2 minus negative 5, be careful, 2 minus negative 5 is really 2 plus 5, so we'd have 7x. 5 minus the bottom 5 is 0, so that's why our y's cancel. And then negative 6 minus 50 gets us negative 56. And then from there, we're going to divide both sides by 7. So negative 56 divided by 7 is going to be negative 8. So we found the x-coordinate. We know there's one solution. We know the x-coordinate is negative 8. We now have to find the y-coordinate. You can go back to either of the original equations to plug in negative 8 for x. I'm going to go to the top. So 2 times negative 8 for x plus 5y equals negative 6. So we have negative 16 plus 5y is equal to negative 6. I can add 16 to both sides, and I'll have 5y equals 10. And then I divide both sides by 5, and I have y equals 2. So the lines cross at negative 8, 2. There's one solution. Now, let's say you wanted to add. I could have 2x plus 5y equals negative 6. On bottom, I have negative 5x plus 5y equals 50. So if you say to yourself, I want the y's to cancel, okay, I need to subtract. Well, if you want to add, you can go across the whole bottom row, and go across either actually, and change all the signs. So if you see negative, you change to a positive. You change the positive 5y to negative. You change positive 50 to negative. So you go across the bottom and change the signs. Now you can add all the columns. So 2x plus 5x would get you 7x. 5 plus negative 5 would be gone. Negative 6 plus negative 50 would get you negative 56. And if you notice, you're still going to get the same answer. You should, right? X is negative 8. And that's what we got over here. So you can go across one of the rows if it's going to help you, be able to add the columns, and you'll still get the same answer. Let's go on to the next one. Okay. So you have two options. If you want to substitute your setup, right, you can plug x minus 1 into the top equation for y. So you would have negative 4x plus 3 parenthesis x minus 1 is equal to negative 2. Distribute the 3, you'd have 3x minus 3, negative 4x over here, equal negative 2. So negative 4x and 3x is negative 1x, or negative x, minus 3 equals negative 2. Add 3 to both sides. So you have negative x equals, or you can put that 1 there, equals positive 1. You have to divide both sides by negative 1. X equals negative 1. Sometimes people forget to do that. It doesn't say x equals, it said negative x equals. So it has to just say x. So we know there's one solution. We know that these lines are going to cross at negative 1. Now we need to find the y coordinate. Go back to either equation and plug in negative 1 for x. I'm going to go to the bottom. So negative 1 minus 1, so we have y equals negative 2. Now, if you want to do elimination, you need to make sure the x's and y's line up. So I have on top negative 4x plus 3y equals negative 2. If I subtract x from the one side, I get negative x plus y equals negative 1. Now my x's, my y's, and my constants are lined up in columns. Now right now, neither the x or the y's would cancel by adding or subtracting. So I need to make them cancel. I need to make them, help them eliminate. So if I choose to eliminate x, what I told you guys to do is, you can think about it, it's not really cross multiplying, but you multiply the opposite row by the coefficient of the other row. So I can multiply the bottom by negative 4, and I can multiply the top by negative 1, right? So if I did that on top, I would have positive 4x minus 3y, need to distribute to all terms. Negative 2 times negative 1 is positive 2. The bottom, I would get positive 4x. Negative 4 times positive y is negative 4y. And negative 4 times negative 1 is positive 4. So now I look at the x's. I ask myself, what do I do? Add or subtract? If I add, I get 8x. If I subtract, I get 0x. They eliminate. Now, if it's a subtraction problem, if you need to subtract to eliminate, I can go across the bottom, and if I want to add, I can change all the signs on the bottom. So 4x minus 4x is gone. Negative 3y plus 4y is y. 2 minus 4 is negative 2. And that's what we got over here for the y coordinate. Or, if it was set up as 4x plus 4x on top plus 3y equals negative 2, and on bottom if it said 4x, let's see, 4x, what do we have? 4x minus 4y is equal to positive 4, and you chose to subtract to eliminate, you'd have to go across and subtract all terms. So we'd have 4 minus 4 would become 0, 0x. 3 minus negative 4, 3 minus negative 4 is really 3 plus 4, or 7y. And negative 2 minus 4 will get us negative 6. I'm going to retry that. Something didn't look right. Because I know y should be negative 2. Ah. Let's find that. Let's try that again. So So if I wanted to do elimination, we could rearrange. So we have negative 4x plus 3y equals negative 2. The bottom was negative x. If I move stuff around, plus y equals negative 1. I could multiply the top by negative 1, multiply the bottom by negative 4. So on top I'd have negative 1 times negative 4 is 4, 4x. Negative 3y is equal to positive 2. The bottom we'd get positive 4x minus 4y equals positive 4. If I subtracted all, I get 4 minus 4 is gone. Negative 3 minus negative 4 is negative 3 plus 4. So we have 1y equals negative 2. So y would equal negative 2. Check. And then if I chose to go across, instead of subtracting, and change all the signs on the bottom row, I'd be able to add, right, if I changed all the signs on the bottom row. So negative, positive, negative. So negative 4x plus 4y equals negative 4. And if I added everything up, those cancel, add these up, I get 1y. Add these up, I get negative 2. Okay, check. So you can do it either way. And let's look at this last elimination problem. So if the bottom has a coefficient of 2 and the top has a coefficient of 1, I could say, okay, multiply bottom by 1, multiply the top by 2, right? So if we go across the top and multiply everything by 2, we would get 2x plus 2y equals 24. The bottom would still be 2x minus y equals negative 6. Now I would have to subtract, but I like adding. So if I choose to add, I know 2 plus 2 would be 4. So if I choose to add, I need to go across the bottom row and change all the signs. So this becomes negative, this becomes positive, and this becomes positive. So now 2 plus negative 2 is gone. 2 plus 1y is 3y. 24 plus 6 is 30. Divide by 3, so we get y equals 10. We know there's one solution. The y coordinate is 10. Then to find the x, I go back to either original equation. So I have x plus, I'm going to insert 10 for y equals 24. If I subtract 10 from both sides, I would get x equals 14. So we can say the x value is 14. So these lines cross at 14, 10. Now, just want to remind you guys, if you had a problem like this, negative 7x plus 4y equals 0, and you had positive 7x minus 4y equals 0, and when you started to eliminate, everything canceled. On one side you have 0, and on the other side you have 0. If everything cancels and it's a true statement, 0 equals 0, 5 equals 5, then that means many solutions, because it would be coinciding lines, same. Okay, if you have something like this, negative 7x plus 4y equals 5, and 7x minus 4y equals 3, if you add and everything eliminates on the left and you have 0 equals 8, it's a false statement, so that would be no solution, because if you graph, the lines would be parallel.